All right, guys, so this is our warm-up for the day. Components of the universe e-ticket. So you're going to label the diagram using the following words: universe, galaxy, planet, and solar system. So each letter corresponds to a word. So for example, if you think that A would represent a solar system, then you're going to write solar system on this line. I'm going to give you about 2 minutes to do that. All right, about 30 seconds left. All right, so we're not going to go over that right now because I want to see how your answers change over this lesson. All right, so go ahead and take out your Cosmos Study Buddy. So here is the term. This is where you're going to write the word. And here is the definition. So the definition is inside of the PowerPoint. And the word is right next to it. So you need to follow along and make sure that you write the word where it goes when I show the definition. Do not fill in the visual portion right now, okay? Do not fill in the visual portion. So let's begin. When we study the universe, we sometimes study it as a well-ordered whole, which is also called cosmos. So whenever we look at how everything in the universe works together, that is called cosmos. So we're looking at the really big picture and all of the small things inside of it. A space where no matter is present is called a vacuum, or it can be called void because there's no matter. So there's not even an atom there, nothing there. So where there is nothing, no matter, it can be called a vacuum, or it can also be called void. So our two words right now are cosmos and vacuum/void. How is the universe held together? So the universe is held together by gravity. The gravitational attraction is what's keeping it together. Gravity is affected by two things: the mass of an object and the distance between the two. All right. So the attraction is affected by the mass, which is not weight, and the distance between the two. All right, so components of the universe. A component is just something that comes together to make something bigger. All right. So you guys could be like the components of the components of the school. Okay. The building blocks of something. Galaxies. This is our first component of the universe. So the galaxy is the biggest part of that. That's a component of the universe. It's the biggest part. A galaxy is a system of millions or billions of stars held together by gravitational attraction. All right, so a galaxy is inside of the universe. The universe is the biggest, then the galaxy. So we're working our way from largest to smallest. Galaxies are classified by their shape. Okay, we have 3 different shapes that we're going to be focusing on. There are others that we're not focusing on. Elliptical, I always call it the egg. Spiral, it has these arms extending from it. And then irregular, it has no definitive shape. So just to recap those, irregular, no definable shape. It's not a spiral and it's not an elliptical. Elliptical, I call it the egg. So this is an example of an elliptical galaxy. Spiral galaxies consist of a flat rotating disk with stars. All right. So it has these arms extending from it, kind of swirling out. So we have 3 types: irregular, elliptical, and spiral. What galaxy do we live in? So if you didn't know, we live in the Milky Way, and the Milky Way is a spiral galaxy. All right. So here's an example of, well, this is actually of the Milky Way, but you can see that it has these arms extending from it. So not all spirals have the same amount of arms, and we are located on the arm, right? About right here on the Orion arm, and we're this little small speck in space compared to the entire galaxy. All right. So we live in the Milky Way, and it is a spiral galaxy, and we are located on the arm. So this is very important, and it's on the second page of your study buddy. So if you want to flip on the back in the second section, you can go ahead and fill these answers in. So I'll give you a minute to do so. So these answers are on the second page. Well, not these answers, these questions are on the second page. So see if you can find out where they go. And if you can't, it's okay. We're going to talk about it again anyway. All right, so we're going to go ahead and continue. So here's another picture of the Milky Way. So the Milky Way, again, is a spiral galaxy. All right, so we're located on the arm of that galaxy. So about right here on the arm. All right, so now you guys have a galaxy card sort. So on your table, you should see a stack of cards. And I want you to sort them into the 3 types of galaxies. So if you forgot, spiral, irregular, and elliptical. All right, so I'm going to give you 3 minutes to do that, and then we'll recap. All right, guys, you want to be wrapping up your final selections. We have about 40 seconds left. All right, that's our time. So let's recap and let's check your answers and see where you put your different galaxies. All right, so the first one that we're going to talk about is spiral. That's one we're going to focus on because it's the Milky Way, and that's where we live. So the following are the spiral galaxies: C, E, F, B, L, and K. So double check your answers, and if you didn't put these in the spiral section, then you can put them in there now. So I want to make sure you can identify a spiral galaxy no matter how the picture looks. All right. So the next one is elliptical. The elliptical galaxies, don't forget that they look like an egg. And the following ones are elliptical: D, H, and I. D, H, and I. All right. Irregular. So these don't have any definite shape, and they are G, A, and J. G, A, and J. All right, so I want you to turn to page 2 of your study buddy, and we're going to go ahead and complete this section. So you're going to complete this section right here. It says, draw a diagram of the different types of galaxies, then answer the question. So here you're going to draw a picture of a spiral, of an elliptical, and then of an irregular. And then you have some questions that follow. So I crossed out the ones I did not want you to answer, which are number 3. And then this one down here at the bottom that my screen is covering up, but I'll show it to you. I'll move my mouse and you'll be able to see it. So what is the name of our galaxy? We're going to answer that one. How are galaxies classified? Describe where our galaxy should be. Describe where in our galaxy is our sun located, And then galaxies are composed of blank of stars, all right? So I'm going to give you about 5 minutes to do this. Yeah, 5 should be enough. We'll make it 6, just because you're a good class. And feel free to use color if you like. If you don't want to use color, that's a-okay with me. Go run your bath water. It's 11:30. Okay, bye-bye. All right, guys, we're about halfway through the time, so make sure you have your galaxy sketched and you've answered the questions, please. It's the final countdown. All right, guys, you have a couple of seconds left. So if you're still filling it in, which you shouldn't be, go ahead and wrap it up in 5, 4, 3, 2, 1. All right. So your pictures, the spiral galaxy has arms coming out of it. Elliptical looks like an egg. And irregular has no defined shape. So you could have literally drawn anything. What is the name of our galaxy? That was the drum roll, please. My drum roll sucks, but Milky Way. How are galaxies classified? We should have gotten by their shape. Describe where in our galaxy is our sun located. So our sun, which is our star, is located on the arm. And we didn't answer what type of galaxy is shown because we didn't have that particular image. Galaxies are composed of, you can have millions or billions of stars. All right, so millions or billions of stars. All right, next, quick check. What are the three types of galaxies? All right, so we should have said spiral, irregular, and elliptical in any order. What type do we live in? So we live in a spiral galaxy. And where in it? Where are we located in that galaxy? And that will be, we are on the arm. So we live on the arm of the Milky Way in a spiral galaxy. All right, let's take a 3-minute brain break just to regroup. So feel free to talk to each other, talk to your friends about other stuff that's not dealing with science, and I'll be back in 3 minutes. Your water finished, baby? Just check it, okay? Huh? Okay. Ba-da-ba-ba-ba. All right, so our brain break, gee whiz, I know what's wrong with me, is over. So we're going to move into the solar system. So the solar system, hint, it's underlined, which means it's one of your vocabulary words, is a collection of celestial objects that orbit a star. easy way of saying it. It is a group of planets that orbit a star. Okay. It can be also asteroids, comets, moons, all that good stuff. The word celestial just means anything that's outside of our atmosphere. So anything in space, like Earth, is a celestial body. Our moon, our stars, asteroids, comets, they are all considered a celestial body. Okay? So our solar system is just a collection of celestial objects that orbit a star. And what is our star? It is the sun. Okay? So the sun would be a proper noun because it's the name of a particular star. All right, so just here's a quick little picture of a solar system. This is ours. All right, so of course you see that it includes comets, asteroids, and planets, and even dwarf planets. And here's our beautiful star, which is giving us all of its energy, which is the sun. Things that are outside of Earth's atmosphere is called celestial or celestial body. It's underlined. So that means it is a term for your definition. Examples of celestial bodies: planets, sun, moon, asteroid, comet, and star. These are just a few examples. If you find others, cool. But a celestial body is just anything outside of the atmosphere, anything that is in space. How do we measure stuff in space? So you need to know the difference between the two. This is not, one of them is on your study buddy. Light year is on your study buddy. Astronomical unit is not. So if you have your notebook, just jot the differences down. And the only thing that you need to know is light year is we measure things inside of our galaxy. So it has to be inside of the Milky Way for us to use light years to measure it. And it is the distance that light travels in 1 year. Astronomical unit, or AU for short, it's how we measure things that are outside of our galaxy. So if we're measuring from Mars to Earth, that's inside the Milky Way galaxy. So we're gonna use light years. If we're measuring from Earth to something outside of the Milky Way, for example, the Andromeda galaxy, then we're going to use AUs, or astronomical units. So light year inside, AU outside. Maybe you can remember it by saying you turn on the lights inside the house. So light year inside the galaxy, astronomical unit outside. I don't know if that'll help, but if it does, use it. If not, hey, I tried. Quick check. So let's read the question. And then we will rock, paper, scissors on 3. So let's take a look. Let's take about a minute and just everyone read the question, and let's choose an answer, and I'll be back in a second to go over the question. All right, we're going to rock, paper, scissors on 3. 1, 2, 3. All right, you can put your answers down. So I'm going to answer this question using a process called Think Aloud. So that is where I actually share how or you will share how you answer this question. So I'm going to get one of my little pencils here, and I'll just use red. All right, so I'll start by reading the question, and then you can look and see if you got it right. The Milky Way galaxy is described as a disk of stars orbiting a central point on the disk. Doesn't matter. That's cool and all, but that's not an important part of the question. Which of these best explains why people on Earth cannot see the shape of the Milky Way? So, first thing we have to think about is, what do we have to know to be able to answer this question? We have to know that Earth is located inside of the Milky Way galaxy. So if Earth is located inside of it, how can it ever see the entire shape? Can't. You can't see the entire shape because it's located in there. So let's eliminate the most common ones. The stars in the center of the galaxy are extremely small. We know that that's a lie. The sun is our star, and it's several times bigger than the Earth. Stars are huge. Many more stars exist outside the galaxy. The center of the galaxy consists of a dense cluster of stars. Okay? We can actually eliminate both of these because none of them are explaining why we can't see the entire shape. The only one that makes sense is A. Earth is a part of this galaxy. We are located inside of the Milky Way. We're never located outside of it so that we can see it like an aerial view. Okay? So the correct answer was A. If you got that right, good job. If you didn't, it's okay. We'll keep going, and we'll be able to answer it soon. All right. Looks like I have to erase all of this. Oh, there we go. Perfect. What's inside a solar system? So the first thing is planets, and it is underlined. Planets, a celestial body moving in an elliptical orbit around a star, Jesus. You can see it's my bedtime because my words are starting just to slur together. A celestial body moving in an elliptical orbit around a star. All right. So here's just a visual. You have the planets, and you also have their moons that are around it to show you that that is a celestial body as well. So the planets are moving around a star, and our star again is the sun, which is a medium-sized star. A comet. A comet is ice, gas, and dust, and a tail of ice pointing away from the sun. All right? Ice, gas, and dust, and a tail of ice and dust pointing away from the sun. All right, so we just did planet as a component, and now we just did comet. So comet and planet. Asteroid. One of the scariest things in the world to me. An asteroid is a rocky body orbiting the sun found in the asteroid belt. So find that definition on your paper. And it's found in the asteroid belt between Mars and Jupiter. So we've learned three things just now: a planet, a celestial body orbiting a star. It has an elliptical path. We learned about comet, right? Gas and dust. It has a tail of ice pointing away from the sun. And asteroid, a rocky body that orbits the sun that's found in the asteroid belt. Drum roll, please. And now for the final, most famous component. It is the star. A star is a large celestial object that is composed of gas and emits light. So a large object outside of the atmosphere that is composed of gas and it gives off light. All right. So here is just a picture of what we see, how we see stars from Earth. We're going to look into how they look actually in space, like when you're close up on them, using images from the Hubble telescope. All right, so make sure you've located that word on your study buddy. So our biggest misconception. So I wanted to go ahead and dive into this. Look at our little bitty sun here. Here's our sun, and here's Antares. Our sun is nowhere near the biggest star. Our sun is a medium-sized star, and you're also going to learn about the life cycle. So just how humans are born and they grow up and then they die, or a butterfly, or whatever you want to think about, a star has a life cycle as well. A star is born and it also dies. So one of the biggest misconceptions that I wanted to address before we began is that the sun is nowhere near the biggest star. It's actually a medium-sized star. And here it is, this little bitty smidget right there. All right, life cycle of a star. So go ahead on the back of your study buddy. You should see this image, and this is what we're going to start filling in today. So these images are going to correlate to the different steps of the life cycle of a star. All right, so use your notes to complete the diagram. I'm going to do it with you on the board right now. And then these two questions I'm going to answer in this segment as well. So we're going to go from the beginning all the way to the end. And I'm going to explain how you have these two different pathways. All right, let's go ahead and get moving. Stars. A star contains hydrogen gas that forms helium through a process known as nuclear fusion. So gravity comes together and pulls together gas and dust, and it forms something called a nebula. That word right here, nebula. Stars release a lot of energy. They can become very hot and glow. We know that already. Stars vary in their mass. So you have some very small stars and some really, really large stars. They also vary in temperature and their age because they have a life cycle. Now, remember I said, all right, so now that we know what stars are, we've talked about how they vary in size, temperature, age, and we've also talked about nuclear fusion. So we're going to talk about nuclear fusion just a little bit more. So what is nuclear fusion? It is when two small atoms fuse together and become one to make a large atom, and it gives off a tremendous amount of energy. All right. So don't forget that you're going to be needing this section of your study buddy. And let's go ahead and get started with the life cycle of a star. So the first step for the life cycle of a star is called the nebula. Nebula. The nebula is a cloud of gas and dust. So let me explain that a little bit further. So imagine that we're inside this room, in the classroom, and I throw glitter all over the floor. I spread it all the way out, all over the entire floor. That would be a huge pile of glitter, which would be like a nebula. When I sweep all of that glitter up into one small pile, that would be a star. A nebula is way more vast than a star. And a nebula is also called the nursery for stars. So it's where a star is born, it's where it comes to life. This is the first step in star formation. So this is going to be nebula right here, the first step in star formation. So write the word nebula right below this picture. So a cloud of gas and dust, nursery for stars. This is another way to remember nebula. So everybody has seen this spider web little stretch pack. Okay, and then when you spread it out, like you say, this covers 800 square feet. So this little tiny bag becomes this. Star, nebula, all spread out. Star, packed together tightly. Nebula, all spread out. All right, here's a picture of a nebula. So it's just gas and dust spread out. And it is the first step in star formation, also called the nursery for stars. All right, so we've just answered 3 questions. What is considered the nursery for stars? Nebula. The path a star will follow is determined by the star's mass. And the first step is nebula. Okay, so now we're going to move on to these arrows. Our next arrow, it's called main sequence. So this right here is the next step, main sequence. It's the step right after nebula. So about 90% of stars spend their time in this stage. I like to call this stage adulthood. So when you're first born, you're a nebula until you're about 18. Just give you an example. From 18 until you die, that can be 70, 80, 90 years old, you're an adult for all that time. Same thing with the main sequence. Once a star leaves its nebula phase, it becomes a main sequence star. So 90% of our stars, including the sun, is in this phase right now. These stars can be very small, like 1/10 the mass of the sun, or they can be 200 times as massive as the sun. All right, so a big size range for the main sequence phase. Okay, so the main sequence is after nebula, so that's going to go right here, main sequence. So nebula, main sequence, and then these two are determined by what again? Mass. So if it's a massive star, it's going to go this way. If it is an average mass star or medium mass star, it's going to go this way. All right. So we have nebula, main sequence. All right, now we will focus on massive stars, which will be the top part of your organizer. So go ahead and focus on this section right here. This is the section that we're going to focus on. And if you want, you can write the word massive above it, because this is going to be where the massive stars go after main sequence. Every star goes to main sequence, and then it goes to a different place that is based upon its mass, right? A massive star leaves main sequence and becomes a supergiant. So this phase right here is called a supergiant. So right on this line, you're going to write the word supergiant, right? Here it is again, supergiant. Supergiant stars are the largest stars in the universe. They can be thousands of times bigger than our sun and have a mass up to 100 times greater. The largest known supergiant star is VY Canis Majoris, and it is 2,100 times the size of the sun, right? So we're going to wrap up right here. So just to recap what we did today, we started with the cosmos, which is the well-ordered universe. Then we talked about galaxies, 3 different types: spiral, elliptical, irregular. We live in a spiral galaxy known as the Milky Way, and we're located on the arm of that galaxy. And then we went into stars. So stars have a life cycle that are based upon its mass. And then we have massive stars and average size stars. Okay? So at this time, could you go ahead and pack away your things, clean up your stations, and go ahead and stand behind your desk and prepare for dismissal? Thanks.